So, greetings of the day. Welcome to the course on Operations Research Technique. Students, in Unit 5, we have covered analytical part of individual replacement model. In last lecture, we have covered all required aspect for analyzing the problem of group replacement. There we have seen various assumptions, what are the favorable situations in which we should go for a group replacement, that we have studied in last lecture of group replacement. And we have seen when it is applicable. Just recall, first, unit cost of item is low. Second, large number of similar components are involved. Large number of similar components are involved. Third, probability of failure increases with time. And the components are required in a very large number. And most important, we have seen there is large setup cost associated with it. Now, when we want to analyze the problems pertaining to group replacement, there will be certain requirements of the data to analyze. So that we'll see. Now, group replacement. In group replacement, I have already explained you the concept in last lecture, that after some time we will be replacing all components in a group in spite whether they fail or they do not fail, but in between we will replace the components only those have failed. Now, when we want to do analysis, so various parameters will be involved. Total number of items or components, that we will be calling it as n. Total number of items or components, that will be calling it as n. Remember, if this n is not given in the problem, you can assume it. So if not given in a problem, choice is up to you, that you can assume value of n as 1000 or 500 or 2000, like that. But it is better if you assume value 1000, it helps in calculation. So I am leaving it up to you what to assume. Preferably I have said assume 1000. Now this is first. Second is, what you need is cost of item. Cost of item, that data will be needed. And in cost of item, if cost in group replacement, cost in individual replacement, cost in group replacement, cost in individual replacement, and here we are abbreviating it as CG, and here it has CI. This is the notation which we will be using. Then this is the very essential data that is required for analysis in group replacement model. Then very important category of data, that is probability of failure of item. So here period, suppose period, and if the unit I am writing is week, suppose data is for 5 weeks. This is very important to understand. Then probability of failure, PK, I am abbreviating it as PK, for different periods, So suppose 0.1, 0.2, 0.2, 0.15, so it is 0.35. So see that now when we see probability, total probability, we know that it is 100% in percentage, or in number it is 1. So 0.1, 0.2, cumulative 0.3, 0.3 plus 0.2, 0.5, 0.5 plus 0.15, 0.65, 0.65 plus cumulative 0.7 and 1. Okay, so this is first case. This is first case where you are given, this is first case, case 1, where probability is given like this. Other thing, this is very important, I am focusing on. Other thing is, say second case, how one can give. Again I am writing here how the data may be given. Probability of failure, abbreviation as PK, 0.1, 0.3, 0.5, 0.65 and 1. Very important point of discussion, students. Very important point of discussion. See, I have given you what are the requirements when we want to analyze group replacement problem. Under that, I need this data, total number of items in a system of which I wish to carry out group replacement, that is abbreviated as capital N. If it is not given, I have said assume it as 1000. Cost of item that is required, group replacement cost, individual replacement cost, group replacement cost abbreviated as CG, individual replacement cost abbreviated as CI. Probability of failure, very important data that is required in group replacement. And in that, these two ways of probability data is given. See, for problem execution, for problem solving, I need data in this fashion only. Very important point. I need data in this fashion only, that is, this indicates probability of failure in respective period. We want probability of failure in respective period, therefore I have highlighted. To solve problem, you must have your probability in this fashion only. Again I am stressing, and therefore I have written probability of failure in respective period. So how to check in exam when you are attempting the problem? So students, see that the individual probability given, if you sum it, it has to be total equal to 1, or if it is given in percentage, it should be 100%. Now here I have given in decimal form. Same thing I can write it proportion probability of failure. Proportion probability of failure. So here I will write 10%, 20%, 20%, 15%, 35%. Here I will write 10%. If it is at all in proportion, 30%, 10%, 30%, 50%, 65%, 100%. So you have to be very alert while solving the problem, that the nature in which probability is given to you. We want individual probability. If it is ending with 1 or 100%, if it is ending with 1 or 100%, it's cumulative probability. It's cumulative probability. Students, remember, here only I am showing you how to convert this individual probability into cumulative probability. How to convert this cumulative probability into individual probability. Suppose in exam you are given this row and this row. You are given these two rows. First row I have marked, third row I have marked. Keep your attention on this last. Once you check it that it is either ending with 1 or 100%, don't use the same value in analysis. You have to calculate probability of individual failure first and then attempt the problem. How to calculate individual failure probability from the data? Very simple. Write first as it is, then second minus first, 0.3 minus 0.1, 0.2. So this is a result of 0.3 minus 0.1, 0.2. This is a result of 0.5 minus 0.3, 0.2. This is the result of 0.65 minus 0.5, 0.15. This is the result of 1 minus 0.65, 0.35. So when probability is given in cumulative form, subtract, keep first probability as it is same, and for subsequent probabilities subtract second probability from first, and likewise to calculate remaining further probabilities. Very, very important discussion. And third way of giving probability is third case, very important. Probability of survival. Probability of survival. This is the third way of data giving in exam. This is very important. Survival is opposite of failure. Failure is opposite of survival. That you know very well. These are opposite things, survival and failure. I have said that while analyzing problem, we want only probability of failure of respective period. So how the data is given in third category, that I will explain. I will rub this first part that is explained. third part, suppose week same, we will write same week number, week, that is our period, unit is week, and here probability of survival, zero, 1, 2, 3, 4, 5. See students, here I have not started from 0. In first case week starts from 1. In second case also, where probability ends with 1, it starts with 1. But when it is probability of survival, it will start with 0, present moment. And we know that when equipment is new, very new, it is analogous to our human life also. As we grow old, our probability of death increases. But infant, it's more, survival chances are more. So similarly, probability of survival of any component in the beginning is 100. I am saying in percentage, suppose, or if I want to write in fraction, here I am saying percentage. If I want to write in decimal, it is 1. Clear? So what I will do to avoid confusion, I will write here in percentage or proportion. Suppose 85, 70, then let it be 40, 10, 3, like that. Two distinct rows, like this, data is given as got it. So week 5 weeks data and probability of survival like this. What we need to do, what I have explained, that we have to identify. What we have to identify? We have to identify cumulative probability of failure in that particular time period. So from this, what I will write is probability of failure in respective week. Now we know, students, how many weeks we are coming across? We are coming across 5 weeks. So I have to calculate probabilities like this, and see, total sum of all these probability of failure in respective week has to be 1. Yes, probability is always in percentage 100%, or in fraction, if you add all those fraction, it is maximum 1. So for first it is dash. Now what we did here, forward value minus backward value. Here we have to do exactly reverse. So initially at present moment, there is no probability of failure. Survival is 100% means no failure. Now at end of 1 week survival is 85%. Initially survival was, yes, got it? Initially survival was 100. Now after 1 week survival is 85. What is the failure? Simple. Yes. 100 initial survival, 85 present survival. How many failure? 100 minus 85. 100 minus 85, 15. Got it? 15. This minus this. 85 minus 70. 50. 70 minus 40. 30. 40 minus 30. And then 7. See what we are doing? We are going for calculation of the values, different values, and we are in a position to find the values of respective probability in the form of percentage. Once we do that, then our next step is to find the value of number of failures, number of failures in each period. This is very important. Number of failures in each period, and this will be abbreviated as NK. Small n, K failures, K is period, small n number of failures in each period. Now see, the data is like this: period, and Pk is probability of failure. Period 1, 2, 3, 4, 5 like that, and probability of failure, suppose 0.1, 0.2, 0.2, 0.5, 0.3, 0.2. Total has to be 1. Yes. 0.2, 0.3, 0.5, 0.8, 0.11. Now, if this is the data given to me, that I am having the value of individual failure of the component, I am having with me n, that is total number of components. Total number of components. Then in this analysis, what we have to do? We have to find the number of failure in each time period, and this is very crucial one. How to analyze that I will tell. We know, see, these are the probability of failure in different time periods. So I will write this, abbreviate this as, suppose I will write it as 1.1. So what I will do, I will write this for understanding as P1, this as P2, this as P3, P4, and this as P5. For 5 periods, 5 probability. So again, for this to be very precise, what we have written as a probability? What we have written? P1, P2, P3, P4, P5. Now, how to proceed? To begin with, your total number of components will be equal to n. What your total number of, in the beginning, all components are new, so n will be the total number of components, and suppose you are assuming 500, you will write 500. If you are assuming, suppose 1000. Suppose, to understand here, we assume for analysis as total number of components 1000. So here it will be 1000 components. This is very important calculation, students. Now I want to evaluate N1. I want to evaluate N1. Number of failures. What I am calculating is these all number of failures N. See here we are writing NK. N1 number of failures. See, total number of components are N. Of that, what is the probability of failure? 10%. So it is N0 into, what we'll do? We'll write for this also N0 P N0 into P1. So number of failure in first period. Period may be week, period may be month, or whatever time unit given in the problem. I am saying period. If I am assuming 1000 components, so how I will analyze this? What is the total number? NO 1000. What is the P1 probability of failure? 0.1. What is that? It will be how much? 100 failures. 100 failures in the first period. This is how we have to proceed. N2 number of failure in the second period is very important. If your this value comes to be fraction, so we are not breaking the component, so take second integer value then. If we are getting 99.1, we'll take 100. If we are getting 89.5, we'll take 90, like that. N2, see, for this N0 lot, they have probability of failure for second period. N0 lot have probability of failure for second period, plus very important, N1 which you have replaced one time period before have probability of failure P1, have probability of failure P1. So it will go like, for this case it will go like 1000 into 0.2 plus 100 you have replaced here into 0.1. So students, this comes to be 200 plus the 1000, 2000, decimal point 1, 200 plus this is 10, total replacement for second period is 210 item. Very important. If you commit mistake in this slide, in this calculation, entire problem will go wrong. I am explaining all this mathematical procedure in detail, and then when we will shift to the problem, we have already solved problem. There I will remind you that we have seen all these mathematical calculations, how to proceed, and at that point of time I will correlate every aspect which we have discussed over here at that particular problem. Now we have to calculate N3. We have to calculate N3. N3 will be equal to, friends, and NO. For NO, probability of failure, third, it is for NO item which are remaining, it's third period, third week. Some items will fail in third week. Importantly, you have replaced N1 over here. For N1, the period will be second period, and probability of failure in second week, second time period, plus you have replaced in previous period N2 component. For their probability of failure will be equal to P1. I think now you are getting it. What we have to do? This is the formula written. We have to put these values already calculated and get new value. Similarly N4, it is N0 P4 plus N1 P3 plus N2 P2, N0 N1 N2 plus N1, and for their probability is P1. So how you can keep in mind is this N suffix goes on increasing, N1, N2, N3, this should be N3, this should be N3, N suffix goes on increasing and P suffix goes on decreasing. Keep that logic in mind. Last value which we have to calculate is N5. For N5, how it is behaving, friends? N0 P5 plus N1 P4 plus N2 plus N2 P3 plus N3 P2 plus N4 into P1. So this calculation will give you actual mathematical value of number of failures in that particular period. Got it? Actual number of failures in that particular period. Now suppose the data is of 8 week, we have to calculate N8. If data is of 10 weeks, we have to calculate N10. If data is of 5 week, we have to calculate total N5. If it is 7 week, we have to calculate 7 week. Now we are ready with one more decision making parameter for analysis, that is total number of failures. So this is the exhaustive treatment. This is the exhaustive treatment for finding total number of failures of a problem, replacement problem. Now once we are ready with this total number of failure, see, for analysis what we need is total number of items that we need, and that we have abbreviated as N. Then we need second data, cost of group replacement per unit, which we abbreviate as CG. Third data which we need, cost of individual replacement in group replacement, individual replacement in group replacement per unit, which we are calling as CI. This is the data we need. Then we need important data we need, that I will highlight with other color. Probability of failure in respective period. I will highlight this probability of failure in respective period. So I don't want cumulative probability ending with 1. I don't want survival proportion starting with 100%. What I want? Probability of failure in respective period. Then we need, just we have calculated, what we have calculated? Number of failures in respective periods. We want this data which we have just calculated, and that is nothing but it is NK data. This just we have calculated NK, number of failures. So this is one data, this is other data, CG, this is your third data, CI. Now once we are ready with this data, we wish to compare, very important, first what we wish to compare? We wish to compare average cost of group replacement per period. Also we wish to calculate average cost of individual individual replacement per period. I am saying per period. See here, in both analysis, my point is very important. I want comparison to be made, and for that unit has to be same, and for that I am taking unit as per period. If it is period is week, it is per week. If period is month, it is per month. Usually for group replacement policy, we don't have, usually I am saying, period in years. Now what we will be doing, we will be finding average cost of group replacement per period, we will be finding average cost of individual replacement per period. We will compare, and if, see, very important, how to calculate this, that we will see. How to calculate this average cost of group replacement and all that, that we will see. If we calculate this group replacement cost and individual replacement cost, if the situation is that, very important, if the situation is like this, means if average cost of group replacement per period turns out to be less than average cost of individual replacement per period, students, remember in mind, if this is satisfied, your answer should be prefer group replacement policy. Your answer should be prefer group replacement policy. Again I am telling, meaning of group replacement policy is, suppose I am getting that group replacement minimum value at the end of 4th week, means after every 4 weeks we will be replacing component in group, in spite they fail or they do not fail, but within this 0 to 4 week period, in week 1, in week 2 and in week 3, you will replace only the items which have failed. But remember in mind, for replacing the items only which have failed, the cost will be CI, which will be more than CG. When we replace the component in group, after particular time period, the answer will come out to be that you have to multiply that cost by CJ. Now, you may come across this situation. Suppose you came across situation reverse, and that reverse situation is like this. Average cost of group replacement per period turns out to be greater than average cost of individual replacement per period. What to do? Just think. So in that case, you will not think of group replacement. You will replace only filled component at that time period, at respective time period, at the cost of CI. No question of bulk replacement, no question of replacing the items in spite whether they are not filled. So decision is very simple. Compare these two costs, but per period has to be same. If situation is like this, we will go for individual replacement policy. Again, there has to be no confusion. So let me explain how to tackle the situation, because students many a times find confusion with this. Suppose this is week data, week period. So this is 0, 3, 6, 9, 1, 2, 4, 5, 7, 8. Let me explain it once again. If your answer turns out to be replacement at the end of every 3 weeks, so I have marked this with bullets like this. So at every 3rd week, 6th week and 9th week, you will replace all the components in a group in spite whether they fail or they do not fail. And here the cost which you will bear is CG. Here the cost which you will bear is CG. Here the cost which you will bear is CG. In between, suppose these are the failures. These are the failures. For this failure, your cost will be CI. For all failures, barring group replacement quantity, cost involved will be CI. This is called as group replacement. But if your answer is go only for individual replacement, then in that what will be the situation? Suppose again this is weeks. Suppose this is weeks 0, 1, 2, 3, 4, 5 like that, and your answer is like this, that individual replacement cost is greater than group replacement cost is greater than individual replacement cost. So what you will do? You will replace after every week, after every period, related NKs with cost CI. So this is how the analysis goes. Now here, for finding average cost, we need to find average life. Average life is very simple. It is summation of year into probability of failure. So we'll stop today's lecture at this point of time, and in coming lecture, in next lecture, what we'll do, we'll take problems where we will apply all this logic. In today's lecture, we have seen exhaustive analytical procedure, how to calculate number of failures, how to compare the cost, and after comparing the cost, what decision is to be taken, and which cost, whether CG or CI, to be quoted for which period, that we have seen. And here, for finding this average life, for individual replacement policy, we need to have the value of probability and value of failure of respective year. Means we will be having year 1, 2, 3, 4, or months 1, 2, 3, 4, or weeks 1, 2, 3, 4, probability of failure. So if I go on multiplication, year into probability of failure, year 1 into probability of failure of year 1, plus year 2 into probability of failure of year 2, plus year 3 into probability of failure of year 3, this will give me average life. So I will stop today's lecture at this point of time. In next lecture, we will solve numericals based on this concept. So till now what you can do is go through textbooks, go through this content and try to understand the insight involved in analysis of this problem.